Uh-oh. It's that time again. Here we go. Here we go. Third gas law, Gay-Lussac's law, is going to be discussed right now. We're going to do the calculations in class. All right. We talked about examples of Gay-Lussac's law. We also said that it's a gas law that involves the relationship between temperature and pressure and a constant volume. And just like Charles' law, it's a direct relationship. Temperature and pressure both rise simultaneously and or they decrease simultaneously. So we're going to follow along here. I'll do the first two calculations. Okay, it's on the website. Make sure you click on the worksheet and print it out and follow along, and then you'll do the remaining three on your own time, and then we'll discuss in class, and you guys should be ready to go. Alright, here we go. First problem says, and you notice I have up here conversions, Celsius to Kelvin, okay, C plus 273, and 1 atmosphere is 101.3 kilopascals. Alright, so it says, if a gas is heated, circle 29 Celsius to 61 Celsius. Right there it's telling you the temperature is going up. And the volume is kept constant. We know that. Okay? That's going to be important because when I give you the exam, all of the problems, okay, they're going to be mixed up. You're not going to have a set of Charles' law or whatever. It's going to be mixed up. So you've got to be able to recognize the unit in what you're given so you know which formula and law to utilize. So you really got to be cognizant of that. So right off the bat here you see it going from 29 Celsius to 61. So that's why you should really get in the habit of underlining or circling key words of rub. Volume is constant. What final pressure would result if the original pressure was 687 kilopascals? So we have our givens. We have 687 kilopascals. Okay? Our initial temperature for now is going to be 29 degrees Celsius. Our final temperature is going to be 61 degrees Celsius. Our P2 is going to be our unknown, our final pressure. We're going to do a little conversion on the side here. We're going to convert this to atmospheres. So we're going to take 687 kilopascals. What unit goes down here? Kilopascals. Up here goes atmospheres. 1 atmosphere to 101.3 kilopascals. Let me see. Sorry, I'm in here alone. Let me see if that shows up. I just got to see the camera. Hold on one second. It's not that clear. Okay, hold on. Let me see if I can zoom that in for you guys. Whoa. Uh-oh. All right, I'll have to bring it down a little bit. Okay, I'll bring it down a little bit for you guys. Hopefully you can see that a little bit better. Okay. All right, that should work, and then I'll bring that calculation down to the bottom. All right, here we go. Sorry about that. So bring this down here. I had done this. 687 kilopascals, 101.3 kilopascals, right, to 1 atmosphere. The answer for that, cancel, cancel. You should get 6.78 atmospheres. So 6.878 atmospheres is our first pressure. Temperature, let's convert to Kelvin. 29 Celsius plus 273 would give us 302 Kelvin. Okay. Our final temperature, 61 Celsius becomes, add 273, you get 334 Kelvin. Okay, now we're ready to go. This is very similar to Charles' law. So the formula is going to be P1 over T1 equals P2 over T2. Alright? So that's our second box. Again, some people ask me, do we need to show 4 boxes? Yes, you do. Okay, you have to, because I want you to show your work in a systematic, organized manner. Okay, this is a really good habit. So many smart kids who work so hard get careless with their work, and they make careless mistakes. What's the teacher supposed to think? Wow, this kid doesn't work hard. This kid doesn't practice. This kid doesn't know it. And it could just be you're not being organized. So we're trying to train you to be organized to show your work. Okay? That's why I'm being that picky. Okay? You've got to learn how to show your work in a neat, orderly fashion. Okay? So important. All right, so here's the formula. We're going to cross multiply. We want to solve for P2. Cross multiply, cross multiply. So now we're solving for P2. So it's P1, T2. See how they come together? Equals P2, T1. See how they come together? All right? Now, what are we solving for? P2. This stays here. We're multiplying. Bring this one over here. So you're left with P1, T2 over T1 equals P2. Okay? So you're isolating for the P2 variable. All right, now, third box. Sing it. Sing it. That little plug-in song. Plug it in, plug it in. All right, what do we have? P2 equals?
Yes, Mr. Templeton.
6.78 atmospheres. Did you all hear that announcement? Did you hear that? That was strange. Okay, 6.78 atmospheres. Time.
Mr. Templeton, we have a tea time at 3:48. 3:48.
Is Mr. Siggins okay? Okay. 6.78 atmospheres times 366 Kelvin divided by 18.5 atmospheres.
No, I'm not here, Mr. Templeton. I'm at the golf course.
There you go. It's Friday, and I'm here. Here we go. We're going to do this problem. So when you get the final answer, you're looking at a pressure of P2 equals 7.5 atmospheres. Okay? P2 is 7.5 atmospheres. So let's check the work.
48 steps from my office.
Let's check our work. Atmospheres, 6.78 is the pressure. P2 is 7.5. Temperature goes up also. Looks great. Let me see how it looks through the camera. Here we go. Oh, I'll move that over for you. Look at that. Perfect. I'll leave that up there for a second so you can see how that works. Okay, looks good. Okay. 7.5 atmospheres. Right there, you see it? Okay. Leave it up for another second, and then I'm going to erase it. We'll do one more, and we'll go from there. Again, this is a work in progress, people. Be patient with me. I'm doing the best I can with these problems, okay? Doing the best I can with filming this. Oh, wait a minute. You know what we had to do? We didn't give a shout out yet. We didn't give a shout out. Today's shout out, I know exactly who it's going to be. Mrs. Long. Former assistant principal here at the Spring 40th Grade Center. Mrs. Long, I got to tell you something. You're a wonderful principal. We miss you dearly. And I got to say one thing about you. I taught both of your kids. And they're great kids. Awesome. But did they have to go to the two most annoying colleges ever? Duke and Notre Dame. I mean, obviously they're smart. They're successful kids. But of all the places to send them to school, Mrs. Long, Duke and Notre Dame, come on now. You could have sent one of them to Pitt. I mean, really. Two of the most annoying schools. But hey, they have great jobs right now, doing well, great kids, congratulations. Miss Long, Brook Elementary, rock on, we miss you. Okay, number 2, here we go. By the way, Miss Long, Pitt now plays Duke every time. We beat them last week, okay? And I'm going to say something else. We play Notre Dame in November. Got news for you. Remember last year how we should have won in South Bend? Guess what, this year, you're going down. Notre Dame will lose to Pitt. Guaranteed. All right, here we go. Number 2. If a gas had an initial pressure of 981 kilopascals and the volume is kept constant, what was the initial temperature if the resulting pressure was 1,872 kilopascals at a temperature of 93 Celsius? Oh boy. Okay. So let's set it up. P1, T1, P2, T2. First box. All right. We got initial pressure 981 kilopascals. Okay. Volume's constant. What was the initial temperature if the resulting pressure, 1,872 kilopascals, and we have a temperature of 93 Celsius? Okay? So we've got to do a couple conversions here, all right? So I'm going to do the conversion right underneath here, just so you see it, although I think you understand it by now, okay? 981 kilopascals. 101.3 kilopascals for 1 atmosphere. Cancel, cancel. Just like that, okay? Your answer should be approximately 9. I'll put it over here and I'll erase it. This becomes 9.7 atmospheres. That's what I'm looking at here. 9.7 atmospheres after doing that conversion. Okay? This temperature down here, we add 273. We get 366 Kelvin. Okay, so we're going to use that as our T2. We still have one more conversion to go. 1872 kilopascals. 101.3 kilopascals for 1 atmosphere. Okay? We got to cancel. Cancel, cancel. Boom, boom. What do we have here? We now have, this goes away. We have 18.5 atmospheres. Okay? So to me, and let me clean this up now. You see how we did that? I'm going to clean this up so you see the new numbers we're working with. Alright, so I'm going to erase this. You saw how we did that. I'm going to erase that too, just so it looks cleaner. And I'll bring this over here. We've got 18.5 atmospheres. Okay, now, formula. P1, wow, this chalk is squeaky, isn't it? Sorry. P1 over T1 equals P2 over T2. Okay, there's our formula. Cross multiplication, we're solving for T1 right here. So we're going to cross multiply these right here. It's P1 times T2. See how we did that? Divided by P2. Okay? This is what we're solving for. Alright? Okay. So that's what we have. P1 T2 divided by P2 equals T1. Okay. Plug it in, plug it in. T1. You know what? I gotta tell you something. You think I'm crazy for singing these songs? You guys ain't seen nothing yet, man. We got some good songs to sing this year. Okay? We have the Rust song. We've got the Wheel and Axle song. If any of you former students are watching, I'm sure you are. You know about that wheel, the Input on the Wheel song. You remember that? Or Transition Metals, right? Remember that Rust song? I'm not going to sing it. You can sing it on your own. I'm not giving that away yet. Okay? It's always fun to reminisce. All right, here we go. We're solving for T1. So we've got 9.7 atmospheres times T2, 366 Kelvin, divided by 18.5 atmospheres. Okay, let me check and make sure I got it set up. All right, good. The answer I'm getting is going to be a T1 is 192 Kelvin. Now, circle the answer. Now, wait a second. What if you're sitting there? And I don't know. I'm going to check it. Mr. Parcier, I can't see the answer. Chill. Wait a second. I'll make sure I move the camera for you again, okay? Again, I'm doing the best I can. Before I do that, though, what do you notice about every number? Every number. Now, get your family around the camera. Get your family around the computer. Hurry up. Go get your family. See? Families, this is quality time with your family. Calm down now. Get all your brothers and sisters. Let's start singing. Here we go. 1, 2, 3. Every number has a unit. Yeah. Notice, every number has a unit. Okay? Very important. Keeps your work organized. And I can't stress enough how important recognizing the unit in the word problem is. Because again, when I mix up these problems, you got to know what formula to use, what law we're using. It's so important to recognize units. It's such a good habit. Keep yourself organized, okay? All right, now let me go behind the camera and see how this looks, and then I'll make sure you can see it really good. Or kind of good. Okay, I'm doing the best I can. Ooh, that's blurry. Okay, here. All right. Okay, so you can see the formula, P1, T2 divided by P2 equals T1. Third box, it says T1 equals 9.7 times 366 Kelvin divided by 18.5 atmospheres. And we get a temp T1 of 192 Kelvin. All right, I'm sorry about the board. I'm doing the best I can, okay? We'll try to work on that as we improve this on-demand channel, okay? All right, so let me get back up here. Maybe we'll look into getting a whiteboard in here soon to help you guys see it better. We're trying new things, guys. Again, we just started, all right? I'm doing the best I can. All right, so we had those two problems. First one was a P2 of 7.5 atmospheres. Second one was a T1 number 2 of 192 Kelvin. Now I'm going to read off the next 3 answers. So you should pause this and do them on your own. What's the point of just writing down the answers and you're not going to learn anything? Just, I'm going to wait 1 second, pause the video. Okay, here's the answer for number 3. Hope you paused it. We have a P2 in 7.2 atmospheres. Number 4, we have a P2 of 6.92 atmospheres, approximately. Okay. And number 5, we have a T2 of 204.6 Kelvin. 204.6 Kelvin. Okay, that's it. Have fun. You better work. 2-day exams coming next week. Okay, it's all fun and games in here, I understand. Okay, but we're pushing you hard here. You better step it up, all right? If you've been doing what you should have been doing, coming for help, doing your work a little bit each night, okay, you should be in great shape. If you held off and have slacked off and not done it much, well, you're in a big hole right now because you've got so much now to study in a short amount of time. When you have that test and you know what these tests are like, okay, you're not going to be focused and you're going to be stressed, okay? So a little bit each night matters. Check in with me if you have any questions, okay? We have SSS every day next week, obviously. You come see me for help. We have Monday, I'll be handing out free tickets for Breakfast Club Without a Breakfast, which is Tuesday morning in SSS. A little brief review session, okay? So that's one thing, extra thing we're doing to help you. Second thing we got, Science Help Desk next Tuesday. Okay, so another opportunity for help. Another thing we have coming up, we have the 2-day exam. Your homework will be collected, the random pages, probably Thursday, the last day of the exam, or Friday. But have it ready by Thursday just in case, okay? I'll collect it one of those 2 days. We have Alumni Day coming up next Wednesday, 2 weeks from now, October 9th. Students from 9th grade will be coming in to talk about how to survive my class all year, how to put up with me all year, you know? So we'll have that. And Science Department's going to develop a video going over some of the basics of Chapter 1, okay? I highly recommend you watch it. We're going to work on that Monday. All 6 of us are going to be in here, you know, helping each other out, helping everybody in the building out. So we hope that you enjoy that. Again, you have to be patient. We're trying our best with these videos, and the goal is to help you learn more efficiently and to actually have you enjoy this stuff. So if you have any questions, write them down. We have a little bit of time on Monday to kind of take a step back. Don't obsess over these calculations. Okay, you have a lot of other material to study. It's very easy to obsess over these calculations. It's very easy to obsess over gas laws because that's the newest thing we're learning. And you kind of blow off and assume you know the old material like 1.1, 1.2, 1.3. Okay? You have to know everything. Everything counts. A little bit each night matters. Okay? Make sure you study, and that's it. Alright? I'm done. I'm tired. Time to go home. Bye.